Hello, hello. Okay, so today's paper is BERT for evidence retrieval and claim verification, and authors of which are Amir, Soleimani, Christof, Monz, and Marcel Worring. Okay, mm, okay. Let's start with it. Let's see what this paper has to say. Okay, what it is about. So this is the abstract. BERT for evidence retrieval and claim verification. The name of the paper it is. Okay. Now abstract, let's dive into the abstract. We investigate BERT in an evidence retrieval and claim verification pipeline with the task of evidence-based claim verification. To this end, we propose to use two BERT models, one for retrieving the evidence sentences supporting or rejecting claims, and another for verifying claims based on the retrieved evidence sentences. To train the BERT retrieval system, we use pointwise and pairwise loss functions, examine the effect of hard negative mining. Our system achieves a new state-of-art recall of 87.1% for retrieving evidence sentences out of fever dataset, which is of 50k Wikipedia pages, and scores second in the leaderboard with fever score of 69.7. Okay. Now let's come to the introduction. What is it about? What is the main idea behind the paper? Okay. Let's see the introduction, otherwise I'm not getting anything. The constantly growing online textual information has been accompanied by an increasing spread of false claims. Therefore, there is a need for automatic claim verification and fact checking. The fact extraction and verification shared task introduces a benchmark for evidence based claim verification, making it possible to integrate information retrieval and natural language inference components. Fever consists of 185k claims labeled as supported, refuted, or not enough info based on 50k Wikipedia pages done. Okay. So the task is to classify the claims and extract corresponding evidence sentences. The task is to classify the claims and extract the corresponding evidence sentences to evaluate the retrieval and verification performance together. Okay. Fever score is defined as label accuracy condition on providing evidence sentences unless the label is NEI. Okay. So the claim example here they have shown. See, look at the example here. So they have given the claim as Roman Atwood is a content creator, and evidence is he is the best known for his vlogs where he posts updates about his life on a daily basis. Okay. So this is supported, means this evidence goes with the claim. Okay. Now another claim is that Furia is adapted from a short story by Anna Politkovskaya. Okay, and refuted means this was denied. So, and what's the evidence given? Furia is a 1999 French romantic drama film directed by Alexander Aja, adapted from a science fiction story of Graffiti by Julio Cortázar. So, as we can see that this evidence does not give any proof of the claim that is being made, so this is refuted. And in the third case, we see that the claim is made with no proper evidence. So they have labeled it as not enough info. Okay. Okay. So verifying a claim based on 50k pages is computational challenge and can be alleviated by a multi-step pipeline. Yeah, so that's a big data set. Okay, and with a multi-step pipeline, it increases further fold. So most work on fever has adopted a three-step pipeline, that is document retrieval, a set of documents. Okay, on fever has most work on fever has adopted a three-step pipeline, document retrieval. So what is fever? Fever is a data set. Okay, examples of the fever data set are here. Has adopted three-step pipeline. One is document retrieval, A set of documents which possibly contain relevant information to support or reject a claim are retrieved. Okay. Sentence retrieval: five sentences are extracted out of the retrieved documents. Claim verification: the claim is verified against the retrieved sentences. So, firstly, they are retrieving a document, a set of documents which could possibly contain relevant information to support or reject a claim. Okay. Then, sentence retrieval: out of those retrieved documents, five sentences are extracted. Claim verification and claim verification is claim is verified against the retrieved sentences. So, yeah, verified whether the we can derive um, the claim from the evidence which we have. Okay, that is the retrieved sentences. Pre-trained language models, particularly BERT, which is this bidirectional encoded representation transformers, has significantly advanced the performance in a wide variety of information retrieval and natural language processing tasks, including a passage re-ranking, question answering, and question retrieval. In this paper, we examine BERT for evidence-based claim verification in a three-step pipeline. A first BERT model is trained to retrieve the sentences. Okay, see, they are describing a little bit about what their model is doing here. So, a first BERT model is trained to retrieve the evidence sentences. Okay, we compare point-wise cross entropy loss and pairwise hinge loss and rank net loss for BERT evidence retrieval. We also investigate the effect of hard negative mining, which means training on harder negative samples. Okay, next, what is negative mining means? I think on negative samples to show it what it should not, accept as an evidence. Uh, Means what evidence should not be okay to be to support a claim. Okay, yeah. Which means training on harder negative samples. Next, we train another BERT model to verify claims against the retrieved documents evidence. The code is available online. Okay. In summary, our contributions are as follows. To the best of our knowledge, we are the first to use BERT for evidence retrieval and claim verification. Sorry. So they're using this BERT for evidence retrieval first, and that is finding out the evidences, and claim verification. Okay, we compare pointwise and pairwise loss functions for training BERT sentence retrieval, and we investigate and employ H&M to improve the retrieval performance. We achieved second rank in Fever leaderboard. Okay, let's see. This is the related work section. Let's see what else is there. What the method is. Let's see what the method is. Okay, okay. Let's jump into it now. And then if we don't understand, we'll see what can be done. Okay. So Fever provides ND Wikipedia documents where D is equal to ND, that is okay. The document DI consists of sentences. Okay. So there are ND number of documents, Wikipedia documents, where D is equal to D is represented in this way. That is document I to okay. ND is the total number of Wikipedia documents, and D is the set containing all these documents. Okay, the document DI consists of sentences SDI. Okay, and each of those documents contain sentences. Okay, NSDI number of sentences. The goal is to classify, as you can see, this number of sentences. Okay, see this one is like okay, NS subscript S and DI. That sorry. Sorry for the interruption. I think my net went down. I'm really sorry for that. And I hope that the recording is still going on. Yeah, it is. Yeah, so let's see here. What were we saying? This one, right? This formula. The goal is to classify the claim CL for L is equal to 1 to NC. which is equal to, the goal is to classify the claim CL for L is equal to 1 to NC. Okay, claim. Mm-hmm. So there are NC number of claims, and the goal is to classify this claim, okay, as either supported, refuted, or NEI. Okay, not enough info. So these are the three classes that these claims need to be classified into. Okay, NC here is 145K. For a prediction to be considered correct, a complete set of ground truth evidence must be retrieved for a claim CL. The NEI labels does not have an evidence set. We explain the proposed system in a three-step pipeline: document retrieval, sentence retrieval, and claim verification. Figure to demonstrate the proposed BERT. Okay, point 5 sentence retrieval left. Let's see this picture. Yeah. Okay, I hope you all can see the screen, right? So, see, this is a potential evidence claim plus. So, let's see what they have described. Point-wise sentence retrieval and claim verification. Okay, and then the next one is pairwise sentence retrieval, and orange boxes indicate the last states of CLS. Okay, okay. This is the first picture is point-wise evidence sentence plus claim. That is going into the potential evidence sentence plus claim, going into BERT, and then classification layers, and then cross entropy. And here pairwise sentence retrieval, potential evidence, okay, ranking score. Okay, I don't know what difference is there between these two. I can't understand it right now. Okay, okay, let's see. Following the UKP Athene promising document retrieval component, I think. Okay, so they are seeing these. They have development sentence retrieval performance set, sentence retrieval methods. These are all methods for models for sentence retrieval, and they have chosen the UKP. I think, see that it has, I don't know which one they chose, but point wise plus this one has a high precision, and then the others. Okay, point wise plus threshold, as you can see here, shows a good performance, better performance than the rest, I think. Yeah. So following the UKP Athene promising document retrieval component, which results in more than 93% of document recall, we use this method to collect a set of top documents, that is DCL top, for claim CL. We use all retrieved documents as DCL top. Okay. The central sentence retrieval. Okay. Correct a set of top documents. Okay. Now let's see this. The retrieval step extracts the top 5 evidence sentences, that is SCL top. The training set consists of claims and the sentences DCL top corresponding to CL. Okay, and CL, and we can see that CLS is what? Is top. CL is equal to sentence DI belongs to DCL top. Okay, top 5 sentences, evidence sentences. Okay, okay. We use this method to collect the top documents for the claim. What they're doing is that they're first selecting a claim, okay, and according to that claim, they are selecting the top documents for that claim CL. Okay, we use all retrieved documents as okay this, and then again amongst those retrieved documents, what they're doing is that they're extracting extracts the top 5 evidence sentences. Okay, the training set consists of claims and the sentences from DCL top corresponding to CL. Okay. BERT is a multi-layer, so again they're choosing the sentences, top 5 sentences and evidence sentences for that claim. BERT is a multi-layer transformer pre-trained on next sentence prediction and masked word prediction using extremely large datasets. BERT takes the input with special classification embedding CLS, followed by the token representations of the first and the second sentences separated by another token SEQ. To use BERT for classification, a softmax is added on the hidden state of the classification token CLS and trained together with the pre-trained layers. We adopt the pre-trained BERT model and fine-tune using two different point-wise and pairwise approaches. By default, we use the BERT base, that is 12 layers in all experiments. In order to compensate for the mixed co-reference pronouns in the sentence, we add the page titles at the beginning of the sentence. We use a batch size of 32, a learning rate of 2e minus 5, and 1 epoch of training. Okay, and in point-wise approach, we use cross entropy loss, and every single input is classified as evidence or non-evidence. At testing type time, SCL top sentences are selected by their probability values. Alternatively, a threshold can be used on the values to filter out uncertain results and trade off the recall against the precision. In a pairwise approach, a pairwise pair of positive and negative samples are compared against each other, okay, using rank net loss function. We do not force the positive and negative samples to be selected from the same claims because the number of sentences per claim is significantly different. Number of sentences per claim is significantly different, and this results in oversampling sentences from claims with limited sentences. Okay, in addition, we experiment with the model modified hinge loss function. At the testing time, both pairwise functions, top 5 sentences, are selected both for pairwise the for both pairwise loss functions. The top 5 sentences are selected based on their output probability values. The ratio of the negative to the positive sentences is quite high, is high. Thus, is not reasonable to train on all negative samples. Okay, yes, surely, because uh, you can understand, right? Because there is a claim and there will be evidence, and the number of evidences will of course be less, and where they can choose from all these evidences, the number of correct evidences will be quite less, right? So the negative to positive sentence ratio is really high, so it's not reasonable to train on all negative samples for sure. Random sampling limits the number of negative samples. However, this leads to training on trivial samples. Random sampling, okay. This leads to training on trivial samples. Okay, yes. So what they're doing is that they're sampling. That is, they are choosing some of those samples, some of the sentences, or some of the evidences as negative evidences for some sentences. But they may be trivial because this model or may not learn much because they are not exactly negative. They are just randomly we are picking them up and saying that they are not. If we can train it on something hardly negative, means hardly opposite, or completely opposite, going opposite to what the actual evidence is, then the model will learn better. Okay, so that is not the case with random sampling, right? That is what they are saying here. Similar to 13, we focus on online HNM. That is, yes, said here. What is HNM? mm, they were saying here something about HNM, right? I just saw something weird. Okay, hinge loss, I think. Yeah. Okay, let's see. Focus on an online H&M. We fix the positive sample's batch size of 16, but heuristically increase the negative sample batch size from 16 to 64 and train on the positive samples and only the 16 negative samples with highest loss value. Okay. And only the 16 negative samples with the highest loss value. Train on the positive samples and only 16 negative samples. Okay. Fixed positive samples batch size of 16, but heuristically, so what they do as a solution, they fix the positive samples batch size of 16, but heuristically increase the negative batch from 16 to 64. Okay, and train on the positive samples and only the 16 negative samples with highest lost values. Okay. So negative samples with the highest loss values. As I said that um, if you can bring something that is really opposite to what the evidence opposite to the evidence that supports the claim, that is, it does not support. If there is some sort of evidence which does not at all, which can clearly does not support the claim, that will have the highest loss, and that will be selected. Those losses are selected, and for training the negatively training the model. Okay. Yeah. So okay. In this case of pairwise retrieval, H&M selects 32 hardest pairs out of 128 pairs. Lost values are computed in a no gradient mode. Thus, there is no need for more GPU than normal training without H&M. In the claim verification step, each claim CL is compared to and final against this, and the final claim classification label is determined by aggregating 5 individual decisions. Okay, the default label, like 8, the default label is any I, that is not enough information unless there is any supporting evidence to predict the claim label as supported. If there is at least one rejecting evidence and no supporting fact, the label is refuted. If there is at least one rejecting evidence and no supporting fact, the label is refuted. Okay, we train the pre-trained BERT as a three-class classifier. We train the model on 722K evidence claim pair provided by two steps. We use the batch size of 32, the learning rate of 2e minus 5, and 2 epochs of training. Okay, that's what the methodology is. Now let's come to the results. Okay, we need to know more about this pairwise hinge loss and H&M. Okay, yeah, quite high. Model Dream shows the best over here, but Bird and Fever also is showing good accuracy. Good enough accuracy, Bird and Bird, okay. Point 4 is okay. We are showing good accuracy. Although pairwise RankNet with H&M marginally has the best recall, we cannot conclude that it's necessarily better for this task. There is more clear by the trade-off between precision and recall. Okay. Okay. So this paper they've just shown that how good BERT model is working for claim verification task. Okay. Yeah, that pretty well ends this. So I'll leave it over here today. BERT for evidence retrieval and claim verification. Okay. Yeah. Bye.